Hi students. Okay, so this video is going to be to help you understand how to do the calculating how much energy was used to change the temperature of a material. If you know its specific heat and you know the change in temperature, you can calculate how much energy was used to change that temperature. All right, so you can see that I have the specific heat index for iron and aluminum written on the board because the two equations we're going to do are going to be about changing the temperature of iron and aluminum and how much energy was used to do that. All right. This is the equation and you need to write it. I'm a visual learner, so I like color. If the color means nothing to you, you're not a visual person, you don't have to write it in color. But if you're a visual person, you should probably write it in color so that you can keep that idea straight in your brain. Okay? So, how much energy? The units for energy are joules, Joules. So we show that with a J, a capital J, joules. So your answer is going to be in joules. Okay? The specific heat, you write that next. So you have to know how much energy is required to make that temperature change. So everything has its specific heat index. We've been talking about specific heat now for almost a month. So for example, iron requires only 460 joules per kilogram to raise it 1 degree Celsius. That's what this unit means. J per kilogram, which is the mass, and degrees Celsius is the temperature unit that we use. And then aluminum requires quite a bit more. It requires 900 joules of energy per 1 kilogram, which is the mass, to raise it 1 degree Celsius is what those units mean. But you have to carry those units whenever you write it. Whenever you do these equations, you have to show all work, which means you have to show the units so that you can see how they fall out and move around. All right, so here's where you put your specific heat. Now you multiply that times the mass of the material. So in the first example that we're going to be looking at, was it 2? It's got a mass of 2 kilograms. Remember, we use SI in here. So grams are our base unit. Kilogram is what we'll most often use. This is called a delta T. This means the change in temperature. Now your book didn't write it that way, and it's incorrect to not write it that way. Okay, so it's the change in temperature. How much did that temperature change? Because what we're trying to find out is how much energy was required to change the temperature. So you have to have delta T. So that's going to be in degrees Celsius, and it's really important to show all parts of it. Okay, so then page 265. The story problem is how much energy will raise the temperature of 2 kilograms of iron from 20 degrees Celsius to 30 degrees Celsius, and iron has a specific heat of 460 joules per kilogram degrees Celsius. All right, so let's plug and chug. All right, so I'm going to use red. Not sure what I did with the original red marker I was using. I'm going to use red for my specific heat, which is this 460. So 460 joules per kilogram degrees Celsius. So that's my first plug. It said I have a mass of 2 kilograms. So I multiply that times 2 kilograms. And it said that the temperature, and then you multiply it times the change in temperature. I'm going to show you how we get the 10 degrees, okay? So it's a final temperature minus the initial. So it said it went from 20 to 30 degrees Celsius. So you take 30 degrees Celsius minus 20 degrees Celsius. And everybody can see that that's going to be 10, correct? So then when you rewrite the equation, you write times 10 degrees Celsius over here, all right? Now you just plug it into your calculator. You'll take 460 times 2 times 10. So 460 times 2 times 10. 9,200. I'm going to write that in purple because that's my answer. My energy is what I was solving for. It's going to be 9,200, and I need joules. How did I end up with joules? Well, if you're multiplying all the way across here, you might think of it this way. That's over 1. That's 10 over 1. Doing that for a reason. I want you to see this. So I'm going to ignore the numbers right now, and I'm just going to look at the units. This is a joule. It's on top because this means divided by, okay? A joule times a kilogram times a degree Celsius. Hope you see that. This means the same as divided by, like that. That it means the same thing. Okay? So this goes on top. This will go on top. This will go on top. So there's your units. This is going to go on bottom. The reason I end up with joules is that means 1. They cancel each other out. So the only unit that's left is a joule. Hopefully you see it, right? So you're going to do that. We're going to do a practice one then with aluminum. It's on page 265 in the math skills. It says that if the specific heat of aluminum is 900 joules per kilogram degree Celsius, how much energy is needed to raise the temperature of a 3 kilogram, there's your mass, sample from 35 to 45. So your equation is going to be 900 joules per kilogram degree Celsius times 3 kilograms times 45 minus 35, which is going to be 10 again, right? All right, hopefully you'll understand that. And if you have questions, you need to reach out to me and rewatch this and walk yourself through it again. According to the book, this is also in your resources. If you go through Clever and then you get McGraw-Hill, don't click on the actual book, go to the Open app. And when you open the app in your resources, there should be the math practice in chapter 8, lesson 1. So you can watch it their way of explaining it. Okay?